Hi there, my name is Ian Glish, and this is my presentation on the analysis on the carbon dioxide uptake of grass plant samples. The dataset analyzed was based on an experiment testing the carbon dioxide uptake of a single species of grass with grass samples from two completely different origins, Quebec and Mississippi, and exposing them to 7 different levels of carbon dioxide concentration. Before recording the uptakes, half of each origin samples were chilled overnight before the experiment. To get familiar with the data, I used a summary function to get an overview of the data set, which showed me summary information, but most importantly, summary statistics for columns with numeric information. This showed me information such as minimum, maximum, first and third quartiles, the median, and the mean. I realized that the uptake column for the summary showed statistics for both chilled and unchilled treatments variables together. So I filtered the dataset to give me summary statistics on each treatment variables independently. I calculated additional statistics for the columns with numeric information, the concentration and uptake columns. I calculated the range, the variance, and standard deviation. Between the two columns, the ranges were very different from each other. Concentration's large standard deviation compared to uptake's much smaller standard deviations showed me that the uptake data is in a much more narrow range compared to the concentration data. From all the summaries I made and additional statistics that I calculated, I wanted to create some visualizations to understand distributions and relationships from the data. The first visualization I made was a box plot that compares CO2 uptake rates based on the type of grass sample. Quebec samples overall had a higher uptake rate and median compared to the Mississippi samples, which had a lower uptake rate and a lower median comparatively. Quebec samples had a larger range of uptake values, where Mississippi had a more compact range of uptake values. Next, I wanted to build on my first visualization by adding the treatment categories to my existing box plot. The non-chilled treatment samples had an overall higher uptake rates and median values compared to the chilled treatment samples. Quebec still overall had higher uptake rates compared to Mississippi. In the experiment, there were 6 total plants per type, with 3 of each type per treatment. I thought it would be interesting to look at the CO2 uptake rate for each unique grass sample, with treatment categories labeled. This box plot was similar to my previous box plot's findings by showing that the non-chilled grass samples had a higher CO2 uptake rate than the chilled samples, and Quebec samples overall had a higher CO2 uptake rate compared to the Mississippi grass samples. From seeing the relationships from the data in the visualizations I made, it led me to wanting to perform a t-test to show the statistical significance comparing the mean CO2 uptake rates between the two treatment groups. I came up with my null and alternative hypotheses before performing my t-test. My null hypothesis is there is no significant difference in the ambient CO2 uptake between chilled and non-chilled treatment groups. My alternative hypothesis is that there is a significant difference between the chilled and non-chilled treatments of the grass plants, with non-chilled grass having a higher uptake of ambient CO2. The t-test returned 4 metrics and the means of the 2 treatment groups. The t-test results suggest that the non-chilled treatment has a significantly higher CO2 uptake rate compared to the chilled treatment due to the difference in the means. The non-chilled mean was much higher than the chilled mean. The significant difference is supported by the p-value and the confidence interval. The p-value was way under the 0.05 significance value at 0.003. The confidence interval ranged between 2.38 to 11.34, and the difference between the means was 0.86, and that falls well between the confidence interval. Because the p-value was less than 0.05 significance value, we can reject the null hypothesis, saying that there is a difference between the two uptake rates, with non-chilled treatment being higher than the chilled treatment. I then wanted to find the correlation between both CO2 variables, ambient CO2 concentration and CO2 uptake rate. I used a correlation function and got a correlation coefficient of 0.485, which shows a mild positive correlation between ambient concentration and uptake rate. I made a scatter plot that shows the relationship between the variables and added in a line of best fit. The line of best fit starts out linearly, but then curves to the right and then starts to pretty much plateau. This shows that up until a point, an increasing amount of ambient CO2 concentration positively directly influences the uptake rate. But at around 350 milliliters per liter, the uptake rate pretty much plateaus, assuming this is showing a CO2 uptake saturation. I then wanted to add in the treatment variable to the same scatter plot to see what else I could find. When I added the treatment variable to the scatter plot, it showed a line of best fit for the non-chilled and chilled treatments. Each line of best fit had different starting points, but both had nearly identical lines, and both had plateaued around the same point at 350 milliliters per liter of ambient CO2 concentration, showing that regardless the type of treatment done to the grass samples, there was the same saturation level between them. From all my visualizations, the t-test, and the correlation findings, I have learned that Quebec-type grass samples uptook the most CO2 overall in both treatments, probably due to Quebec being a naturally colder place in the winter and warmer during the summer compared to Mississippi, which is probably much warmer year-round comparatively. Non-chilled grass samples had a higher CO2 uptake rate compared to chilled samples. Quebec-type non-chilled treatment grass samples performed the best overall. The CO2 uptake rate pretty much plateaued around 350 milliliters per liter of ambient CO2 concentration for both chilled and non-chilled grass samples. And that was my presentation on the ambient CO2 uptake rates in grass samples. Thank you.